Hi, my name is Ella Lee, and I'm here to tell you about redox reactions. A redox reaction is a type of chemical reaction in which the oxidation states of atoms are changed. Redox reactions are characterized by the transfer of electrons between chemical species, most often with one species undergoing oxidation while the other species undergoes reduction. Now let's break this down. There are two different parts to a redox reaction: oxidation and reduction. In these types of reactions, the element being oxidized is losing electrons, while the element being reduced is gaining those electrons. Sometimes it is difficult to determine whether or not a redox reaction is occurring, so we have used oxidation numbers, which are assigned to each element individually to determine what is being oxidized and what is being reduced. Once we have determined the oxidation numbers for each element, then we can see where the electrons are moving. From this, we can determine half reactions. These half reactions will show whether or not an element is being oxidized or reduced. Then we can combine these half reactions into the full balanced chemical equation. In a redox reaction, the high energy electrons in the oxidized substance will be sent to the reduced substance. So, how are we going to differentiate between these two terms? There's an acronym we like to use called OIL-RIG, where the oil is oxidized is loss, meaning loss of electrons, whereas RIG is reduction is gain, as in gain of electrons. Now let's look at an example of a redox reaction. First, we're going to assign oxidation numbers to each element based off of the oxidation rules. In this equation, the manganese atoms have an oxidation state of +4. Meanwhile, each of the oxygens has a -2, creating an overall -4 charge for the atom. Because aluminum stands alone, it has an oxidation state of 0. So does the manganese atom on the product side. It has an oxidation state of 0. The aluminum on the product side has an oxidation state of +3, creating an overall +6 charge, while the oxygen has an oxidation state of -2, creating an overall -6 charge. From this, we can determine that the aluminum is being oxidized. We know this because its oxidation state is going from 0 to +6, meaning it's losing electrons, as in losing its negative charge. The manganese is being reduced. We know this because its oxidation number is changing from a +4 to a 0 charge, meaning that it is gaining electrons or gaining negative charge. Now, let's look at some real-life examples of where redox reactions come into play. We have cellular respiration, medicine, decomposition, breathalyzers, bleach, photography, corrosion, combustion, and lastly, photosynthesis. Thank you so much for watching my video, and don't forget to watch the other videos on oxidation numbers, voltaic cells, and electrolytic cells to fully understand electrochemistry and redox reactions.